Hello, good afternoon, everyone. Hopefully you can hear me okay, and welcome to today's webinar. I'm Alan Jarvie from Atkins, but representing Spaces today. And as part of our ongoing series of webinars related to our study day last year around net zero carbon building resilience, I'm really pleased to have today Tom Holland with us, who's Business Development Manager at Innovaré Systems, and he'll be presenting today on low carbon superstructures. Also joined with Fiona from Spaces, who's in the background making sure the tech's working. So just before I pass on to Tom, just a little bit of housekeeping. So you'll see, those that haven't used the system before, it's a an easy system to use. You'll see there's a chat box. So please, as Tom's presenting, please put any questions or queries you might have in the chat box, and we'll pick up all the questions at the end. So Tom's presentation will allow for a bit of Q&A at the end of the session. So we'll carry on from there. So Tom, over to you.
Just unmute myself. Afternoon all, thanks for coming along. I'm just going to try and share my screen and then we'll start the presentation. So hopefully, there we go, that's good. Okay, well, thanks for coming along. So thanks for the introduction. So yeah, Tom Holland, Business Development at Innovaré Systems. I'm just going to take you through sort of first part of the presentation really focuses on the product offering and how that works for Innovaré to build structures. And then the second part is focusing really on the carbon and the work we've done on carbon calculation. And then the sort of next steps on that as we go through. So getting on with it. So Innovaré Systems based near Coventry, founded in 2005. I mean, we've delivered probably more like 250, 260 schools now. Partly residential, but primarily now an education focused business. Working very well on the MMC1 framework, where we're partnered with Brown & Kirkland, and that has enabled us to put quite a lot of investment into the factory, which I'll cover a bit later. And certainly pretty much just finished our works on the DfE Sustainability School Pilot Scheme at Margin McClure. So I think we're now complete our work, so I don't get that close to the actual builds. And then our offer, well, we're a full design, manufacture, supply and install offer. So I think that differs slightly from traditional sort of timber manufacturing, where a lot of people are a manufacturer and then you would find a installer yourselves, but we offer management that whole sort of life cycle through. And again, our sectors, I mean, education's on there 3 times because that is primarily what we're doing. We're seeing some small amount of healthcare coming through. Again, residential and student is still there, but probably much, much smaller part of what we do. And also because we're using timber, we are limited by the sort of 18-metre rule on combustibles in the external leaf of the building. So we're very conscious of that as well. In terms of our solutions, I mean, we're always trying to sort of push the envelope, see what we can do. And we offer kind of different ways of building. So we would do a full structure, which is really those fingers there coming out of that block, which is where we would provide an insulated outer leaf panel, currently a SIP or iFast offering, which I'll show in a minute. And then internally, it's more akin to traditional timber frame, building up the internal walls, and then the floor systems, glulam we can offer as well. Flooring systems, we can offer timber cassette, CLT if required, and precast concrete if you're looking at thermal mass. So that's kind of the full structure. But then what we also offer is what we call the wrap solution. So on the purpled out area at the back, that was more of a steel frame concrete structure. And then using our panels, for want of a better word, to clip round the outside and form that insulated outer leaf. The reason it went down that route, that particular building is Broxbourne, those sort of the central core area, there wasn't very good alignment. There was halls, there was circulation spaces. So we worked with the contractor on that and found the most efficient solution for the overall build was to go down that route. And that's what we're trying to do with our early engagement, is find the right solution for the project overall, not just for Innovaré. And then this kind of illustrates, hopefully that's going to play, there we go, illustrates that principle. So this would be the full structure, so the insulated out leaf, that one particularly on the ISIP, and then the timber frame internal walls. And then the flooring system. So this was actually precast. I think we're fairly unique in offering precast floors within the timber frame market. But we can also offer, like I mentioned, timber cassettes and other systems if required. So that builds up the sort of full structure. We can provide precast stairs and lift shafts or timber, depending on the solution required. And then roofing, we can provide a cassette system for the roof, or again, precast, depending on the thermal mass requirements. And then again, that's the sort of insulated outleaf panels going on to sort of a normal structure. So what we're seeing is actually that wrap might work as quite a good solution on DfE 21 plus projects with certain contractors we're talking to. So that might be of interest going forward. So in terms of the product offering, Innovaré is really founded on the SIP panel. So that's an EPS core, bonded, pressure bonded on the outside with OSB, and then like a structural timber frame around it. So really good in terms of a lightweight structure, very thin for U values, really good for air tightness. So really good historic product, still in manufacturing. We're still delivering it on schools in certain areas and on other projects. What we are finding though is that the market has really slowed down on the SIP. So the SIP will go out of production this year, actually, as the production line's going. So what Innovaré did, really looking at the market, was develop what we're calling the iFast. So this is, I mean, to be very technical, it's not a SIP. It's a closed panel timber frame system because it's not bonded, it's screwed together. So this is essentially a timber frame. It's non-combustible insulation, stone wool, or the canal equivalent, and then a CP board on the outside. And the advantage of this is obviously it's a much less combustible panel. So this in build, you typically have one layer plasterboard internally, rather than on SIP you need two. But also in terms of temporary fire, in a temporary fire condition when you're building a project, this reduces the need for some of the mitigation quite a lot in some cases. Excuse me. And this does meet the DfE 21 plus specification, so it's non-combustible. Provides we've got air tightness. Compared to a SIP, it is thicker for the same U value, just because, as we know, for that sort of mineral insulation. And what we're also offering on the MMC1 framework is pre-fit of cladding and windows at factory, and we're hopeful of developing that offer out, certainly for windows, for other clients in the future as we expand production. And then really the latest development is what we call the SciFast. And this is aimed primarily at passive house schemes. So that would be our passive house solution. So the Sci value is very low, U value very low, and we get the air tightness to the passive house requirements. We'd achieve that by using, as I think you'll see, the passive purple paint on the internal face. So this is how we get the air tightness, and we're delivering that on West Coventry Academy at the moment, and there's 3 or maybe 2 or 3 other schools in design at the moment along passive house principles. So that's something I think is really interesting, and something we can help solve. I think you've got large format pieces, it makes air tightness a lot simpler, I think. And in terms of that sort of full structural build up, so the image on top left, that's how we would connect in the precast. So there's that angle bracket on there, some connectors and some grout will go in. And then in terms of timber cassette, it kind of sits within the structure as well and the build up. So I think looking at carbon, there's a real discussion about the materials that go in, the fabric first approach. Obviously timber cassette is great and low carbon, it's lightweight, so it reduces the amount of steel that goes in. But it depends on your M&E strategy, because with the precast concrete, that's left exposed, so that provides thermal mass. So I think there's a real question about where the carbon goes into the structure. Does that then reduce carbon in use? And I think there's a good discussion about that. And these are the kind of discussions we want really early to find the right solution on the project. And then in terms of our sort of wrap or infill, so again, that's actually showing the iSIP, but the iFast principles are very much the same. infill wrap onto a traditional steel or concrete frame. That one on the right there is actually a student accommodation Southampton. Might be a bit high for current regs, I think, but at the time, certainly within regulation. And that's something that we're looking at as we go forward on all projects, finding the right solution. And then whilst, we love a rectilinear box, we can also form the interesting structures, and that might be introducing more steelwork again within our package, and then wrapping or infilling with the would be the IFAS now going forward to form that insulated leaf. And what you would see on sort of sports halls as well, we would be introducing some glue down more steel structure in there to get the spans, and then laying the panels perpendicular to those to the beams across. But we have solutions for sort of many building types, obviously primarily education still. And then our air tightness details, and obviously with the SciFast, the passive house panel, that's absolutely key, of course, 0.6 air changes per hour. But then others as well. Base solution would be offering a 5, 3 and 1, and we've got different sort of methodologies and membranes for doing that. But we know that we can close that performance gap. We know that we can provide it because it's a tested, manufactured system. So we know that this is going to work for the air tightness we're saying it's going to. Just an idea of a looking build, really, timber panels and concrete planks. I'm sure most people on this have seen that build methodology before. And then a slightly more sort of hybridized sort of structure, a bit more steel and sort of timber on that one. And again, the middle photo, it sort of shows a sports hall in build. So it's showing we can go up sort of 8 meters high on the panel. So it covers, I think, most sports halls. But that's obviously a big part of what we do, sports halls as well. And then a bit more detail, just going on to that Boxborn Academy again. And we're picking up everything we need. So we provide that steel work. Some of that is in there for disproportionate collapse. Some of it is in there to provide support on that concrete. So we're spanning usually internal corridor wall to external wall, and then perpendicular to that down the corridor. And an ideal structure for full structural for Innovaré, we get the external walls and the corridor walls to line up through the build, and then the sort of partition walls, we've got a bit more freedom on where they go. But ideally, if we can get some good line up, we can make it work really well. And again, that's part of that early discussion, stage 1 and stage 2, what can we do to help to get really good, efficient use of the system? And then really, big question, obviously you mentioned SIPs, timber and fire, because, wood, as we know, does burn, but we're really clear that we've got the right data, the right knowledge in the business, and our technical manager sits on the Structural Timber Association Fire Council, that body. Has got really good knowledge about how fire performs and how we can deal with that within the structures. But what we're also doing is saying that we've tested a lot of testing, and that particular one is on the ISIP on various build-ups, gives various fire performances. And the same on the IFAS as well. See the staggered stud there. And what we found on the IFAS, actually, those staggered studs, you can see in the section, they were originally put in to stop thermal bridging and try and get the psi value to a really good performance. But what it's also done is improve the fire performance because those are now wrapped 3 sides with a non-combustible insulation. So they perform better than was expected in testing. So it's a real good win. And what we can then, boil that down to is our, tested UCAS accredited data. We can issue out the document. There's a link to the BRE report. So we're trying to get the data out there. Just say, look, this is how it's tested. This was the result. And then in conversation with fire engineer designers on the project, find the right solution on build-ups, etc., that will work for the project as a whole. Excuse me. And then our K10 school specification sheet as well, we can provide that data on sort of build-ups, testing, everything we've done on that. And again, we're just trying to get the right data out there as much as we can. And then working through, we have our sort of standard details that we would issue out as part of the project. So 180 plus now, I think. And I think the SciFast now has a whole set of standard detail as well. So we'd issue those out really early. They are details that would be robust, but not robust details in the sense of testing, but they will give a good idea about what is the best way of building with the Innovaré system, and then how we can help develop out to get the best out. But that obviously shows that, in particular, external wall, precast plank, brick support, give you an idea of data. And then, excuse me, in terms of who we are, well, we're based in Coventry. We are a business. We're full of decent, nice people. But we work to the sort of 5 Ps: the places, people, planet, productivity, and proven. And kind of what we're about. We're business, obviously. We're here to manufacture, install great structures, and hopefully make money doing it. But we want to make good things. We're here for the long haul. We've been going 17 years, I think it is now, as a business. Intention is obviously to keep going for as long as we possibly will, and provide really good places. So an idea, that idea of architectural freedom that I mentioned earlier, is still possible. This was a rack project, so these are our panels sitting externally onto a concrete frame, and then helping to form out the truncated pyramids and the overhangs on the awning there. And some of the structures, obviously, for full CAD and BIM capabilities we go through. And then our people, I mean, this, we got through the pandemic as everybody did. We're now working hybrid. Most people are home-based, but most people are hybrid in the office a couple of days a week. But we've still got our extra over cleaning going. Obviously, factory, there's a lot of touch points. So there's extra cleaning still going on at the factory on those touch points to try and stop any spread of COVID as it's still out there. I guess other infectious diseases as well. And we split through the pandemic into 2 shifts just to protect production. And I think June 20, on the right year, was highest production month ever for Innovaré, even in the pandemic. So we managed to keep going, as all our businesses did, become more robust. Planet, I will do a bit more on carbon in the sort of second half of the presentation, but we would state by using timber, you really can drive carbon out of a structure. That's where we are. Also find nice lightweight structures as well to add it, but that's what we're trying to look at. And then really, and I'm sure most people have seen this before, the idea that if you're building with timber, you're starting really from a lower carbon point anyway. It does grow naturally. It's growing in the rain and the wind and the sun out there at the moment, maybe where it's a bit warmer. And it is a fully renewable resource. So we're using well-managed forests. We're using PEFC certified timber. So we know that we've got that chain of custody from forest to factory. And then obviously we're managing it from factory out onto the building site. Productivity, well, we are, BIM level 2, working towards BIM level 3. We'll be using the Revit models, and that's now actually driving the machinery on the shop floor as well. So that does our timber cutting. It can do our board cutting as well, and actually controls the production line for the iFast as well with stops and the way that we manufacture that, which I'll show more of in a minute. Really good about the way of integrating our sort of CAD CAM data. So I'm sure you've all seen CAD models before, but the little tags on the bottom image there showing how we're controlling that data that then goes out to shop floor. And then really taking that through to build is still a fast build system because theoretical max panel is about 4 meters by 8 meters. So the big panels that are going to come in, more usually for education, 3.4, 3.6 high, 7.5 meters, kind of class and bay width. But what we're trying to do really early in that process is talk about build programs as well, be that with a contractual client, to analyze our models and say, like, how quickly can we get it built? Where are the critical areas to build that you need first? And then we'll work our build order accordingly, and try and get handovers at something like an 8-week rolling sort of schedule once we're on a bigger project. But again, by discussion on each project. And then proving, like I said, 250 odd, 260 odd school buildings now. Really good accreditation levels, excuse me a second. And working hard just to make sure we're doing everything right. And then the automation I mentioned down there. So as I referenced earlier, the MMC1 framework has allowed a lot of investment into the plant, and that is the iFast production line on the middle photo, the left photo. And that's a semi-automated line now. I suspect there'll be more investment goes in as we go through the years to get that more automated. Just an idea of some of the things we've delivered. Yeah. Some interesting structures as well as the vector linears. And then digging into carbon, I mean, I'm sure most people on the call are aware of the sort of challenge we're facing. But there's a statistic out there that we need to build to house humanity to a good level. We need to build a new Paris or a new New York every week for a year for the next 40 years, I think it is. So there's a massive amount of building we need to do, and there will be limited resources to do it. And, by utilising timber, we hope that it's renewable, we can keep going with it, as well as obviously the pressures on steel, concrete, as we go through the next millennium or so. And then as we lead into DfE, we know that, the School Estate's 2 times the size of the Isle of Wight, so it's a massive estate that's managed, and all the carbon that contributes. And then really looking at DfE, as we know now, it's net zero operation carbon right now, moving towards, I think, 2025, where we get to full zero carbon. And net zero carbon. We believe we can support that probably right now, actually, in some of the structures we're doing. So this circular twin was work we actually carried out, Morgan Sindall, hopefully not competitors on there going to get annoyed, but along with Skate, Cundall, HLM and Lungfish. So this particular project took an existing build that was built on the Wirral, I believe, and then remodeled it using the lowest carbon tech pretty much that was available market-wide. So the reductions you can see by doing that, and obviously we know that we compete. We know that we're competitive, commercially competitive, because we're still in business and still building, but we know we can contribute to getting the carbon down. And that particular build, that will achieve the REBA 2030 and the LETI 2030 challenges. So we're already there, we can do it, and we're ready to go. So I think, again, most people are probably aware on the output spec of the DfE 21, but we lean sort of heavily on that, and we'd expect that to go out other areas of the education market as well, as that sort of framework is running now. So we know that we can achieve the net zero. We've worked, as I mentioned earlier, the Margin McClure, need to get some site photos, but our work's now complete. So then we look at the whole life carbon. Again, I'm sure most people on the call know, but upfront carbon, A1 to A5 on the RICS, obviously we have a big impact on that as Innovaré, because that's our raw material, our transport, manufacture, and then the actual build process as well. So that is a big part of what we do. But then I think we can actually also influence the whole life carbon, because by building well-insulated structures, well-insulated airtight structures, we can reduce energy usage. And that's really going to help, obviously, going forward as the national grid changes, becomes more renewable as well, like electric heating. And as the national grid gigawatts are going to drop down over the next 50 years, the more insulated structures are going to be needed as well. And then end of life, we'll touch on that a bit. And then again, as I mentioned, just to re-emphasize the timber usage, and then really getting into our carbon calculation tool, which we've developed up. And this takes Rockwood Academy in Birmingham, which we built with Morgan Sindall. It's a worked example, but we can provide a carbon calculator on a project-by-project basis. Takes quite a bit of work, so we do need to know that we need to do it, and then we can offer that as part of our service. Bit of background then, Rockwood Academy, 2,200 square foot over in Birmingham. And this is our standard build structure, so nothing unusual in there for us. So what we've then developed is the tool with KLH Sustainability, or quite well known in the market. And I think it was a bit of a shock to Innovaré, actually, how much information KLH were looking for in order to do the assessment. So they're very, very, very dedicated to getting the right levels of carbon, going down to where the screws come from, all that kind of information. So we can now drive this out of our Revit models to get an idea of carbon. And then what we can drive out of that is a use or indication of the overall carbon in the build, and then obviously our componentry. So this first example is external wall, which is brick slip, and brick slips are relatively high carbon, a lot of stainless steel. Still got to make the brick, which is quite high energy, but that gives an idea that obviously, and then using our timbers as sequestration, which is obviously a matter of discussion as well, the sequestered carbon. Moving on to the internal wall, a lot less because obviously it's got the brick slip on it, but again, our sequestered carbon. And then concrete floor. As we know, concrete is in and of itself a big polluter, a lot of energy going into concrete. So that's something, that's that question early on about what is the right solution. So with precast concrete floors, no sequestered carbon and a high carbon output. So that's sort of key discussion early on. And then if that could have been a timber, you can see the reduction. So real key question for us is how to get an efficient structure, one that's going to work with the M&E strategy, but be as low carbon as possible in the works we're doing. And that's something we're really keen on discussing. Again, that early engagement. And again, really sort of good comparison there, I think, between the two sort of methodologies. Obviously, the walls are remaining the same. You see the project totals are drastically reduced, and the sequestered carbon would go up a lot if you were to use a timber cassette floor. And then look at biogenics, and there's different ways we can cut this data, but gives an idea of the sort of information we provide and where we want to drive it as well. And then the idea on sort of sequestered, I is probably debating. I think under the RICS guidance, you don't really take sequestered because it's going to be released at some point. I don't know. I always thought this a bit like the curves in the pandemics. If we keep going like this, we're going to flood the NHS and we're going to have too many people in A&E. There's not enough A&E beds. So we take action now. We took action, we stayed at home, and then we got the curve down and we kept it below the line. So I sort of think about that in this terms. And the more that we can reduce carbon now, the better it's going to be in the future, because we're not going to get that sequential build up of that carbon. So it's something I think we do all need to consider, which I'm sure we'll do. Then we want an award for Morgan Center, which we'd like to put in because we're great. But really good project for everyone, I think, that one. And then really the idea that obviously it's factory manufactured, so rework should be a lot less, because these are large panelized elements that are coming in from a controlled environment. And then corrugated emissions and sort of some of the future that we're looking at. Again, this sort of high automated production line, and now looking at pre-fitted windows and cladding at factory. Again, target being that I think really we like to offer windows out in a more general aim, but there's a learning curve we're going through at the moment. And obviously providing a near full through wall solution, really good, I think, for the off-site. And then construction stage, obviously lower carbon. We've only got, I guess, 4 to 5 operatives per crane. Still using cranes, obviously high energy, but 4 to 5 operatives on site. So hopefully less miles to the site. Still a discussion on how obviously got to get materials to factory and then from factory to site, but we're taking that into consideration in our calculations. And the benefits of what we're doing, I mean, we are, as I said, large panelized, we are quick and we are lightweight. So hopefully, it does obviously depend on ground conditions, but we would want to see a reduction in concrete compared to some heavier build systems in the foundations. So again, that would be a lot less carbon and time on site. And then also our overall build is very quick. And again, providing those really high insulated, high performing air tightness structures, very key in what we're doing. And then the use really, I mean, I can tell you how good it is, but the air tightness, those structures, the sort of what you see is what you get, the no performance gap on what we're delivering. So this is a series of schools which were delivered with Mid Group, who are unfortunately no longer trading, but the Robert Clack, Lower, Upper and Lymington. So working with same design teams at Bombine to get really good efficiency gainings, looking at, I think, layouts and orientations, obviously windows, and then using the sensitive values of the panels. You see you're driving down the sort of energy usage, 60 kilowatt hour meter square. I mean, that's, well, as it says there, below the REBA 2030 challenge. And that school because of that excellent energy performance, actually was saving about 50k a year on their fuel bill. And that's actually before the current price rises. So what that did was allow them to employ 2 teacher assistants to help the kids whose English wasn't the first language. So there's a real, okay, it's environmental gain, there's energy gain, but that commercial gain has provided a real social gain for that school as well. So as an all-encompassing thing, I think that's really, really good indication of what we can do. And we're just waiting for figures of Boxboard and Helena Vermanis as they've been built, I think. And then end of life, all part of the sort of carbon question. I think, as a panelised system, we can dismantle the build. And I think, the iFast, we should be able to dismantle those panels or evaluate what they're doing. The SIP panel, because they're bonded and where you get glues, makes recycling a little bit harder. But, there'll maybe usage for them as insulation in future builds. But also, there'll be people out there generating this circular economy. And I think that's part of the, part of the sort of future, really, how we develop the circular economy. And people cleverer than me will be doing that. Well, the music, this is us, really. So we exist. Oh, it's skipping, isn't it?
Do you want to stop it and I'll play it on the video link?
Sorry, that ain't working.
It's okay. Hi Tom, I can play the video off of the YouTube channel.
Yeah, shall I stop sharing?
Yep, if you stop sharing.
Yeah, sorry about that.
It's okay.
Okay, cool. Thanks, Fiona. And I think that's pretty much the end of the presentation. The next slide just asks for questions, which I think people have been popping up. And yeah, with that video, hopefully the next stage of that video, we'll see that panel installed on a building. That's the aim of the sort of next stage of our development of the multimedia experience.
Great stuff. Thank you, Tom. And anything else, or should we let you catch your breath for a moment, and then we'll have a look at the Q&As that have come in. Yeah. So
I'm all good. Yeah, great.
Fantastic. They have a drink of water or whatever, and so we'll start. So thank you to everyone. Thank you, Tom, for presenting to us today, and thank you all for putting some questions in the chat box. I'll start from the bottom and work my way up. And there's a question from Lloyd Evans, and really for everyone. Lloyd's asked, will a copy of the PowerPoint be available following the webinar? And the answer is, Fiona said yes. And this comes out, keep an eye, it will come out next week on the YouTube site. But I think there's a link gets emailed out as well, so you'll see that next week. A question from Gregory Ratcliffe. So to you, Tom, how does the whole life cycle carbon emission compare to other frame types?
It's going to, yeah, it's that question over sequestration, I think, and the usage. I mean, what you would find, and again, down to M&E strategy, but on a pure material basis, we're going to be a lot less than a concrete structure. And I would imagine, again, less than a steel structure, given the energy amount of carbon that goes into steel and concrete. However, I think if you look at the RICS guidance, it's about the end of life as well. So they would assume that the timber's then just going to release that carbon in 60 years' time. So I mean, I would say we're going to be a lot less, really, than a discussion about the sequestration and moving on that way. Hopefully that answers that one. I think you're on mute.
Sorry. Hopefully you can hear me now. Yeah. So there we go. And yeah. Thanks for that. So Chris has raised something, and I thought something around fire might come up really. So fire safety has been pretty well covered, but insurers are also worried about water damage with timber construction, whether from flooding, sprinklers going off accidentally, or any other issues. Any thoughts on that?
In terms of well, flooding and looking at, I guess flooding outside in. If you look at the STA guidance, really you're looking at getting the timber 150 and above ground level. But what we would also be looking at is if there is any flood risk in the area, by discussion with the design team, about how high the timber should really be. So I've built structures that have, more of a stub wall on them to get the concrete higher, but then the timber spring off that. So that'd be terms for external flooding and trying to manage that. In terms of sort of internal sprinkler usage and temporary wetting, those are things that need sort of a bit more management, I think. I think if sprinklers go off, it's about managing it out pretty quickly. I mean, given that these are sort of slightly more robust than the traditional timber frame, I would say, you can probably manage it a bit better than you would in a traditional sort of open timber system. But I think you're right, it's about careful management and, previous schemes I've worked on, whether you talk about having a sump pump at the ground that would indicate if it's on, if you've got any water levels at ground floor, but then also trying to make sure that, if there is a leak, it's visible. That's a bit of a discussion about detailed design as well, I think.
Yeah, it's one that, around the clear up and the impact on materials and getting the things back up and running, almost business as usual, particularly in a school environment. So, yeah, it's one I'm sure the conversation will carry on. But Chris, I think you're dead right to raise that. Chris raised another question actually about early schemes in the prior to school building program using SIPs had timber floors. But experienced problems with vibration due to footfall number through coming through and sound transmission. Moving to concrete floors resolved that. Do the current generation of timber forms perform much better?
I'm not sure what it would compare to, but we've got a like a standard cassette, which is timber sort of I-beams and OSB over, but we can also offer the posi joist, the open metal web joist as well. Now, I'm not 100% sure how they compare on vibration to sort of previous generations. In terms of acoustics, you would be looking for maybe a bit of a build-up on top for footfall, if that's the impact acoustics that you're talking about.
I'm just wondering, it's sorry, a little on the spot, but expanding that a little bit. Do you know roughly as a percentage, how many are going in as concrete and how many are going as timber? Are you still seeing people going down the timber floor and cassette route, or people reverting to concrete, as Chris has indicated?
It's probably more concrete at the moment as a percentage, I would say. But I think the driver there, you get different drivers of concrete. Obviously, you've got thermal mass. You do have the acoustic and vibration, and the fire performance is also built into that concrete plank. So they're heavy, obviously physically heavy, higher carbon, but they give those advantages. Whereas the timber cassette, lower carbon, lighter, but needs more finishing on site. And that is that finishing, I think, is where you're going to get your acoustic build up on top or below if you need it as well. But I would say I think we're more concrete floor based at the moment.
Yeah. Okay. Thank you, Tom. Philip Jordan raised a question and came just slightly late, but thanks very much for all your showing, albeit I missed the first few minutes, so I'm clear about how dealing with existing schools as a product.
So
I think it's probably, I mean, your product tends to be around, well, your product tends to be around extensions and new builds, doesn't it, rather than fabric, I suppose, fabric improvement of existing buildings and that sort of thing. You talked about a wraparound, but whether that wraparound product, I suppose, for me, and similar to if I'm interpreting Philip's question right, and please put in the chat if not, but you know, almost this retrofit type system where there's the ability to put the wraparound in existing building rather than what you class as a wraparound around steel or a concrete frame.
Yeah, we're having discussions with some local authorities who are going back to the steel frames of the 60s, and they're obviously trying to retrofit onto that. And there are early discussions about how you would then go and clip an iFast panel onto that existing frame once it's stripped back. That would be how we can make that work. I think in terms of sort of more normal retrofit, those kind of things, that isn't something we'd really get involved in. But if you've got a big structure, then we can come and clip that on, or on the Innovaré, is it Innovaré, the passive house sort of refurb kind of methodology. That's something we're looking at as well. Yeah, but that's kind of, they're quite early really in this sort of stage for us.
Yeah, so Phil, I think probably Innovaré's products at the moment tend to be extensions, new blocks and new schools. Todd,
new build is going to be 90.9% of what we take.
Yeah, it's around the new build school program. Yeah, okay. Todd Reedman, are there limitations to the uninterrupted floor spans that can be achieved when using the timber floor cassette system? If so, does this preclude it from certain settings?
It's timber cassette, it's about 4 to 5 meter span. So if you're looking at a typical classroom, say that's going over that. So we need to introduce intermediate members, and it's how they sit, whether we can get them up into the floor zone to then try to not affect the M&E, routing it's on the ceiling, or whether they sit low and we talk about them in a different way. But yeah, you do need extra beams, etc. typically with a timber cassette.
Okay. What I mean, I don't know if you know, what generally is the maximum spans that you can run using your system?
Well, timber cassette's 4 to 5 meters. The concrete, 7 to 8 meters. I think we're 200 mil hollow core, so that'll just be driven by the hollow precast. But the timber cassette, if it's 4 to 5 meters, we'll put an intermediate member in and then span over.
Yeah. Okay. Thank you. Question from Gregor, and Gregor, I'm unsure. Your contractor. I'm unsure the background of your question, but we looked at Innovaré before on our PI insurance. I understand Innovaré can only offer 5 million. Our requirements are 10 million. Has this been looked at?
It's always been discussed, but it's still 5 million at the moment.
Okay. Any other questions from anyone? Works on the client side. Thank you, Gregory. Okay, if there's no more questions, I mean, there's one other thing I just out of interest really, how sort of inflationary increases, some of the skills challenges we've got at the moment, how's that affecting Innovaré as a business at the moment? Is it, are you having to constantly look at materials that are going into your products? It's a difficult time, isn't it?
Yeah, short answer is yes, it's very difficult. We are, because we use lots of different materials, they're all moving at different rates. So it's actually quite difficult to get a good fix on it. But what we're offering is an inflation projection, trying to look at those materials and what we can do over, I think it must be about 6 months. So we can typically fix about 30 to 35% of it. and the others are variable. And we're trying to give that projection so that 6 months' time, this is where we think it's going to be on current performance. But you're right, it's hard at the moment, as I think it is for everyone. In terms of labour, I mean, factory labour, we're in quite a competitive area, so there's a lot of other people around there. In Coventry, Birmingham, those areas, there's quite a lot of factory work, so we're trying to get the right people in. And if you get down to the sort of site crews as well, you know, we need to grow that skill base, as I think timber frame does generally, because it's slightly more specialised what we do, the crane work, the heavy lifting, those kind of areas. You have to get the right people on that, and that's about keeping our supply chain, well, you know, close, really.
Yeah. Okay. No, brilliant. So, any other questions? If not, we'll wrap it up then. So, just want to say thank you very much to Tom for his presentation today. Thank you all for joining. Just a couple of other events coming up for spaces for your diary, really, and to be aware of is that every year there's the annual Building of the Year Awards, and the entries are open at the moment with a deadline on the 17th of February. So it'd be great to see some additional entries from you all. And actually, the very successful study day as well is back. I think Reading is where the location is going to be this year, moving from Leicester. And that's, I think, planned for around 22nd of June. But keep an eye on that. There's also a number of series of webinars coming out as well, which we hope you might be able to join us. And if there's any content, likewise, that you feel would be useful to share amongst members, please let us know. But thank you again. Thank you, Fiona, for making sure it's all running well. Thank you again to Tom, and we hope to see you at the next webinar. Have a good day. Thanks all.
Thank you.
Thank you.